everyone, I'm Dr. Sonali. Welcome to CSC Core Concepts. In this video, we are going to discuss about the finite automata and how do we design a finite automata. So basically, let us first get started by understanding what do we mean by a finite automata and what are the uses of it. So it is actually a simplest machine helps to recognize patterns. Patterns like any type of strings, if you have a pattern, any type of language set is a pattern, right? So it is an abstract machine which can help you to model any type of computation. So how does it model? It models uses by using the states. Okay, so what is a state? It is a finite number of states, okay, that will show a transition from one state to another, and this transition is based on a set of rules. So let's say if I press 1, my fan will go to a on mode, and if I press 0, my fan will go to an off mode. So on and off are my states, okay, and the rule is that 1 will go to off, 0 will go to on. Understood? So this is a set of rules. So this type of machines or finite automata has widespread applications, like basically it is used in compiler design in order to have check for a during lexical analysis, right? So if you are performing lexical analysis, tokenizing and all, so you have a pattern, right? So to understand the pattern, you will be using the finite automata. Then any type of text searching, spell searching, if you want to identify any keywords or any identifiers, you will use this. For digital circuit design, like your fan or any type of electronic appliances, and modeling simple systems like vending machine. So if you have a vending machine, so what are the states? That first it will give you the list of the menu, then you will insert the money, it will go to the next state, you select the item, okay, it will give you the product, okay. Traffic lights, so traffic light has red, orange and green, so it will go from one state to another, one state to another, then again from this state to this state. Understood? So any type of changing behavior pattern can be studied using the modeled using the finite automata. So how do you represent a finite automata? By using 5 tuples. These are Q, summation, delta, Q0 and F. So what is basically Q? It is the set of non-empty set of states, finite. So how many states it has? Let's say you are using a toaster to toast your bread. So first state is the off state. Okay, then when you switch on, it will go to a heating state, then it will go to a cutoff temperature cutoff state, and then it will go to a final state. Understood? So these are the different states. So a set of all these states is in the set capital Q. Summation is a input alphabets, like what are the possible input you can give. So if I want to have switch on and off of fan, I can have either 1 or 0 as an input, right? I cannot have multiple inputs. Let's say for a washing machine, my input range will be the mode of the washing, that what type of washing you want, a gentle wash, a cool wash, what type of wash you want. So they are the input range. Then you have the delta, which is actually representing the transiting function. Means when you are pressing the switch, then you go from one state to another. So that pressing is one of the function. So you change the state, you get a new state when you perform some input, you give some input to the existing state. So this is your existing state, you give some input to the existing state and you get a new output. So this is what the equation is expressed as. Then Q0 is always the initial state or the first state. Okay, so we start with the initial set, and F is always the set of final state. So you can have multiple final states also. So these states signify the acceptance of input. So consider, let us have a general example. We have a lift or an elevator system. So now there are 3 floors. One is ground floor, one is first floor and another is the second floor. So the lift can move between these floors based on the user input, whatever button he presses. So to design the automata, you first define the states. So here how many states you have? Three states. One is the ground floor, one is the first floor, and one is the second floor. Fine. So input is what? Either you will press 0 or you will press 1 or you will press 2. These are the set of inputs. So inputs is input alphabets is what? You go to these three states, right? Now transition system. So now how will you represent this system? Let's say this is how you represent the initial state. You have an arrow from nowhere which represents this is the initial state represented by Q0. So zeroth floor, ground floor, you have another state which is the first floor, and final destination or final state is your Q2. So now when you press 0, if my lift is in 0th floor and I am getting inside the elevator and pressing 0, I will not change my state. It will not change my state. I will remain in ground floor only. So this is called as a self loop. So while pressing 0 on the 0th floor, I will remain in that same state. But if I press 1, I will change my state from ground floor to first floor. Then if I from the first floor, if I am pressing 0, I will again go back to my ground floor. But if I am pressing 1 in the first floor, I will remain in first floor only. Then if I have pressed 2, then I will go to my final state, that is Q2. So final state is represented using these two circles. And from here if I press 1, I will come back to the first floor. If I press 2, I will remain in the second floor, and if I press from ground floor, if I press 2, I will go to the second floor final destination, and from second floor if I press 0, I will go to the ground floor. So these all are the conditions. They are your delta. And delta is always from the set of inputs. So your input is 1, 0, 1 and 2. So when you are having this input on an existing state Q0, Q1 or Q2, you go to a next state. Okay. And if the next state is your final state, this is how you represent. So this is a directed graph. You represent the automata using a directed graph. Means a graph where the edges have something written on it. The weights are written. Circles, they are denoting your states. So they are these directed edges. Whatever is written on the edges are your transitions. So from initial state Q0, you have an inward arrow. From Q0, you have a self loop. If you are pressing 0, 1, you will go to state 1, or 2, you will go to state 2. So final state is represented using a double circle. Now there are two types of automata. One is the deterministic automata, finite automata, and another is non-deterministic. So deterministic means what? You have determined where you have a determination that exactly which state you will go to. It is not vague that I don't know where will I go, right? So let's say for example, if I am switching on the fan, pressing 1, either it will on or off. It's not like in middle of on off, right? So every electronic appliance, everything is in a DFA only, right? But if I tell the students do your homework and come tomorrow, now that state can be various states. I don't know. You can come, you may not come, you might have done the homework, you might not have done the homework, you might have done the half of the homework, right? So that is human brain. So that is non-deterministic. So in a DFA, for each input symbol, there is only one and one state, that is DFA. So it does not allow any null transition. You cannot have a null transition that if I don't do this, what will happen? No. In a deterministic finite automata, there has to be some input, and when you have an input, you go to some or the other state. Okay. So this is your deterministic. So what it says that this is the initial state. If you press 0, you go to state Q1. Okay. Now after Q1, if you press either 0 or 1, you will remain in that same state. And if you are pressing Q2, you will go to here. If you are pressing 1, sorry. If you are having 1, you go to state Q2. And after Q2, when if you have 0 or 1, you will remain in that same state. So of course, there is some state, but the state can be self also. Okay. And in non-deterministic finite automata, you can move to any combination of states. The exact state cannot be determined. Okay, so as it also has finite number of states. That is why we call it as non-deterministic finite automata, right? Again, here also there are 5 tuples, right, where Q0 represents the set of states, summation is the set of input, delta is the transition. Now here it is different from that of DFA. That is, here the input is given to the existing state. It can lead to any number of states. There it could lead to only one state, right? Here you can go to any number of states. So that is why here it is taken as a power of 2. And Q0 of course is the initial state and F is the final state. So here it does allow null transitions. So F is a final state. Final state is always a subset of total number of sets, obviously. So this is the initial state. You have a null transition, you go to Q1. If you have giving A, you go to Q2. You can have an epsilon. So epsilon represents the null transition. So in my upcoming videos, we will see more and more examples of this DFA and NFA, and we will see how to solve if you are given an input and you are given a pattern, what you want. So based on that pattern and the input, we will design our DFAs and NFAs. So don't wait, simply subscribe to CSE Core Concepts. You can get more and more knowledge from this channel. Thank you.